Good morning, good afternoon, good evening, whatever the case may be. We are back and better than ever, and we are evaluating limits. We do not fear the Reaper, as Blue Oyster Cult says, and we do not fear evaluating limits. The only thing I have to say is we definitely need more cowbell on this song. Let's get to it, shall we? Let's evaluate some limits. We've done some investigation of limits. Now we're going to do these by hand with a little bit of algebra, okay? So let's say I ask you to find the limit as x approaches, let's say 2, of 2x, okay? Well, that's very simple. Remember, the limit is the behavior or the value of the function, that's the function right there, as x approaches the given given value that we're going to use. In this case, it is 2. I'm going to change this to 3x just so we don't get the 2's mixed up. The limit as x approaches 2 of 3x. Okay. Well, when you're doing it algebraically, there's something you can do called direct substitution. That's the easiest direct substitution, and you can use direct substitution when you don't get something that's undefined when you replace x with the value that you're approaching. So in this case, let me erase this. This is simply going to be equal to 3 times 2, which is 6. And it's true, because as x gets closer, that's a horrible 6, as x gets closer and closer and closer and closer to 2, the function 3x gets closer and closer and closer to 6. Let's just take a quick look at that. Like if very close to 2 would be 3 times 1.999, right? That's pretty close to 2, maybe another 9. We hit enter, and that answer is very close to 6. And if x gets closer and closer to 2 from the other side, like 3 times 2.00001, right? Then we get 6.00003. That is very, very close to 6. And that's what the limit is. That's the behavior of this function as x approaches a particular value. That's direct substitution. That is the worst spelling of substitution I have ever seen. Substitution. Did I do this right? Substitution. I'm having pen problems here, so you have to forgive me. Okay. Let's try one more. Let's say you had the limit as x approaches. It's really about to run out of juice, so I'm going to have to go to the mouse, so hopefully it won't be too bad. The limit as x approaches, let's say 3 of x squared minus 9. Okay. Do I get an undefined function if I replace x with 3? I do not. So I would just say that is equal to 3 squared minus 9, which would be equal to 9 minus 9, which is equal to 0. Okay. Well, what if there is a problem? What do we do then? Well, that's when we do a little bit of algebra. For example, let's say I ask you to find the limit as x approaches 4 of x squared minus 16 over x minus 4. Well, if we did direct substitution, we would get, I'm just going to do it over here because it's not going to work. I'm going to get 4 squared minus 16 over 4 minus 4 if I use direct substitution. Well, that would equal 16 minus 16 over 0, or 0 over 0. The 0 in the numerator doesn't matter, but 0 in the denominator is dividing by 0, which is not possible. So the function would be undefined, or the function would be undefined when x equals 4, because you can't divide by 0. So we have to do a little bit of algebra. So we can do direct substitution. So I'm going to say that equals the limit as x approaches 4 of x squared minus 16. That factors into x plus 4 times x minus 4. It's the difference of two perfect squares. Just recall that if I have a squared minus b squared, that factors into a plus b multiplied by a minus b. And sorry it's messy, it's just I'm using the mouse to write with because the pen ran out of battery. Okay, over x minus 4. And what does this do? What does this do? Well, that cancels that out, right? And now I can substitute without the function being undefined. So this equals, I'm just going to replace this x with 4. 4 plus 4, oops, and that is equal to 8. So the answer is 8. Okay? And let's just check that with Desmos. So the limit as x approaches 4 of x squared minus 16 over x minus 4. Okay, so let's get something real close to 4. So let's see. Let's do 3.9. Want to? So 3.9 squared minus 16. And we're going to divide that by 3.9. Remember, it's x squared minus 16 over x minus 4. So 3.9 minus 4, enter, and we get 7.9. And you can see as we get closer and closer, hopefully, let me do like 999, and then put in 3 more 9s here, and you can see we get really, really, really close to 8. And if we came from the other direction, 4.00001, and I did that same thing here, 4 point, how many zeros do I have? 5. 1, 2, 3, 4, 5, 1. We are very, very close to 8. Okay, and that's what limits are all about. Okay, so let's try another one. And hopefully I'm going to try my pen again. So let's say we have the limit, come on now, the limit as x approaches 3 of x squared minus 4x plus 3 over x squared plus x minus 12. So first we'll try direct substitution, and you should try the denominator first, because if the denominator is 0, you're going to have to do some algebra, because that means the function is undefined. And I will tell you the denominator is going to be 0 here, but let's just do it in our head. 3 squared is 9, plus 3 is 12, and 12 minus 12 is 0. So I'm going to have to do a little bit of algebra. I'm going to have to do some factoring. So that equals the limit as x approaches 3 of, this is going to factor, signs are the same, they're both negative, factors of 3 are 3 and 1, x minus 3 times x minus 1, right? You guys know how to factor. And then here the signs are different, and the bigger one is positive, so I need factors of 12 that give me, negative 12 that give me a positive 1, so that is going to be x minus 3 times x plus 4, right? Yes, and so I get this to cancel. And now I can directly substitute 3, and I don't have anything defined. So this becomes 3 minus 1, replacing x with 3, over 3 plus 4, which is equal to 2 over 7, 2/7. Okay. Let me try just one more. Let me see if I can find a good one for you. Let's try the limit as I don't like that one. Here, we'll do this one. The limit as t approaches -2 of 2t plus 4 over 12 minus 3t squared. Okay, and so if we put in -2, -2 squared is 4, 3 times 4 is 12, 12 minus 12 is 0. So I'm going to have to factor this. So up top I can do 2, factor out a 2, and I get t plus 2. 2 times 2 is 2t, 2 times 2 is 4. And here it looks like they have a -3 in common. So I'm going to have a, well actually a 3. A 3 times -4 plus t squared. Okay, and I forgot to put the limit as t approaches -2. Okay, still not good. I'm going to rewrite this as the limit as t approaches -2 of 2 times t plus 2 all over 3, and I'm going to rewrite this as t squared minus 4 because I recognize it as the difference of two squares, the two perfect squares. So, and again, if I replace t with -2 here, I'm going to get a 0 in the denominator. Not good, but things are about to get great right here. -2 of 2 times t plus 2 over 3, difference of two squares, two perfect squares, t plus 2 times t minus 2. And life is just great because this cancels out. And now when I replace t with -2, I do not get a 0. So now that equals, all I have left in the numerator is a 2. And down in the bottom I have 3 multiplied by replacing this t times -2. I get -2 minus 2. Okay. And we simplify that, so that's 2 over 3 times -4, which is 2 over -12, which simplifies to -1/6. Okay, so that is it. I am out. We'll talk more about that in class. Hope you enjoyed it.